Hello, everyone. Welcome to part one in our Balancing Developer and Tester Testing in the Modern SDLC webinar. My name is Christine and I'll be your moderator. Today's webinar features our Logigear co-founder, Michael Hackett. Logigear is a leading provider of corporate software testing solutions and test automation tools. Let me give you a bit of background on our speaker today. Michael is a co-founder of Logigear. In addition to his software engineering work, Michael has provided training for Salesforce, Fidelity, Intuit, Adobe, Bank of America, and many other software producers. His training courses have brought Silicon Valley testing expertise to over 16 countries. He is a certified Scrum Master and holds a Bachelor of Science degree in engineering from Carnegie Mellon University. First, before we begin, here are a few housekeeping items that I'd like to go over. This webinar will be recorded and will be available within 48 hours. Today's part one of this webinar will run about 48 minutes. Part two will run up closer to an hour. Today's agenda is as follows. In part one, Michael will talk about new SDLC ideas on developer testing, test team testing, and QA. In part two, which will happen next week, Michael will discuss what does this look like and closing thoughts. Take it away, Michael.
Hi, thanks for joining today, and let's jump right into it. What I want to focus on today is this idea of developers taking over testing tasks and working with a test team, and how that balances, and this idea of QA, of quality assurance. So I want to talk about first the trends that are happening now, but also about the software development lifecycle and culture changes that are supporting this and helping this along. The next thing I want to do in the second part of this webinar is to talk about what the actual testing looks like. I want to talk about how tester testing is different than developer testing and what the different goals are there. I want to talk about some of the tasks that test teams do, and to think about who's going to be taking those things over and where they're going to fit into this new paradigm. And then talk about how to succeed with developer testing, how to set it up better to reach the desired levels of quality that you hope for, continue the levels of quality you hope for, and then some of the leadership issues that go along with that. So first thing I want to talk about is this trend. So the trend is that developers are taking on more testing tasks, either reducing testing team size or just moving some of the testing tasks over to developers, or in some cases, some companies have eliminated the role of a test engineer or a quality assurance team. So it's happening for a variety of reasons, right? People want faster time to market, or they're narrowing down the focus of their development to minimum viable products or minimum marketable products. And the scale of the jobs is smaller and really focused on delivering customer value faster in a more narrow way. There's also cost savings, right? It's easy math to think, well, if I can have developers test, then developers test, and I don't need these test teams. Well, there's going to be cost savings there. There's also tool changes that are going on. People using the cloud and infrastructure as code and being able to spin up environments whenever you want. So the automated deployment tools and CD tools, there are tools that are advancing this this process of having developers take on more testing responsibility as well. So there's also some, in addition to some SDLC things, there's some culture changes that have been going on to support this, like shift left. And we'll be going into what shift left is. We're going to talk about lean and lean software development, eliminating waste, quality at every step, deliver as fast as possible. So we'll be talking about 3 of the 7 lean principles. And this idea of fail fast. Fail fast is probably the most well-known cultural change that happened after the world became agile, and that fits into this change as well. So the shifting responsibility, it doesn't only rely on developers taking over some of the testing tasks or the tools that can get implemented to help these, making a staging environment whenever you want it, or the other technical things that go into shifting these responsibilities. It's also based on how much you know and understand the customer. We'll talk about this more later on, but the customer heavily figures into this. How much the development team, the software developers, the whatever test engineers you have an understanding of what the customers do and how the customers work. It's also reliant on great user stories, not adequate or okay user stories, but great user stories that give details and acceptance criteria of what the final functionality that's going to be delivered to the customers looks like. So we'll get into that when we talk more about customers. It also is reliant on really understanding customers, right? Really understanding users, that you do continuous monitoring and you find a problem and you update and change it, that your customers are really going to be understanding of that, and that you have good support infrastructure in place, that when the customers, when an issue is missed during development, if a bug or an issue is missed and it makes it out into production, your users are understanding, and support can hold their hand through it, or help them with rollbacks or whatever fixes there are going to be, that those things are easy. Part of the Agile movement is more of a partnership with customers. If we're going to deliver value faster and we're going to give them a minimum viable product to get easy feedback, quick feedback, immediate feedback. People like the feature, they don't like the feature, they want another, they want this changed or they want something else changed. To get that feedback, the users are more partners with the development organization. So if that's the situation you have, where users are partners, and if a bug does happen to get out into production, customers are really understanding about it. That is going to figure into, it's going to make it easier for your developers to take on more testing tasks in this redistribution of tasks. So if the developers are going to take over testing, meaning that they're going to be the main drivers of testing the system, what are the tasks that they're actually going to take over, and what happens to the rest of the tasks that the test teams did? Do they disappear? Do they get distributed somewhere else? That's some of the issues I want to resolve in this discussion. So first, the SDLC changes, then the culture changes. So before we get into the SDLC changes, there's something I want to clear up, or at least talk about, with this idea of testing, which I happen to say testing most of the time, and this QA thing, this quality assurance thing. I tossed up these IEEE definitions. QA is more about assuring, guaranteeing, promising quality. It's much more about practices and process, right? It's about overall quality assurance practices, governance, total quality management from start to finish, quality, measuring quality costs. It's quality assurance is the big umbrella term. Testing is the thing that test teams do. Testing is what developers do when they do unit testing. It's what, when you do, end-to-end tests, or you run your regression suite, you're running tests and you're executing tests with the purpose of finding bugs, with the purpose of discovering how the system works. It's testing tasks that I'm most concerned about. Part of this shift of moving a bunch of tasks over to developers, the QA governance part has been lost in some organizations. That's an important aspect. But also the loss of testing tasks, and having some testing tasks that were done by test teams kind of disappearing is its own issue. So the QA role of the governance or managing the whole set of processes, as well as my main focus is testing and getting enough testing done. But so I have this difference between quality assurance and testing, even though in a lot of organizations, the team that's tasked with quality assurance might be the same team that executes tests. But that's kind of in a case-by-case basis with companies. But quality assurance is the big set of practices governing the whole promise of quality and its practices, where testing is the task of executing tests. So in more traditional development, the progression of testing, simple, kind of goes like this. Developers do a bunch of unit tests, then they do integration testing, then a testing team is going to do system testing, and then somebody else, whether it's users or product owners or an internal usability team or BAs, business analysts, SMEs are going to do user acceptance testing. So the unit testing and the integration testing, fine. We know what developers do there, and they're to show that the functions work the way that you expect them to work. But system testing is a difference. The goal of system testing is much more about workflow on an environment that's much closer to what production environment is going to be like. System testing is where the whole system is complete, no more mocking. The whole system is in place. That's the testing that's probably done through a UI for the first time. That also where if you have multiple platforms to support, like you're supporting, I don't know, 5 or 6 browsers, multiple character sets, different browsers that do encoding of like double byte characters differently, or you're supporting a variety of multiple mobile phones or mobile devices, or this is where you do that variety of testing, because most of the bugs have been cleared out in unit testing and integration testing, and now system testing, UI driven, better to do this kind of device and browser or whatever the final user interface is going to be once the whole system is built and most of the functional bugs are gone. System testing is going to find its own bugs, right? We find, functional bugs in unit testing, interface bugs in integration testing. The UI testing that you do, the testing through the UI and system testing, is where you find workflow, transaction, end-to-end, performance, usability, a whole bunch of the traditional test types that developers have rarely been tasked with doing, and the actual types of testing you do. By the time you get to system testing, the functional testing should be done. The functional validation should be done by that point, and we're looking at very different things, right, in system testing, like platform testing and workflow, transaction testing. User acceptance testing is should be on an environment that's closer to what the production environment is going to look like, whether it's on a staging environment or pre-production environment. And it can be done just as much by users. As I said, what else did I say? Like a UX team, business analysts, seeing that the acceptance criteria, right? There's a connection between the acceptance criteria in the user story and user acceptance testing, where if we need to run this kind of report with these parameters, can I go do that? It's not as much a bug finding phase as it is a validation phase, with as many bugs as you found decided on, deferred, fixed, whatever you're going to do. Workflows that are the workflows that the customers do, done by not technical testers or people who are tasked with finding bugs, although user acceptance testing can be done by a test team. The focus, the mindset here is acting like a user, testing like a user, looking for user style, user type bugs. So in this traditional progression of testing, it's much more common to have developers doing unit testing and integration testing than the product going over to a test team to do system testing or user acceptance testing, or have other people do user acceptance testing. If you're going to move a bunch of the testing tasks over to developers, who's going to be taking over that the system testing? Who's going to be taking over that user acceptance testing? because there's different varieties of bugs that people find with that style testing on those environments. So that's from a traditional perspective of how testing progresses. When we think about Scrum, people moving to Agile and people doing Scrum, right? One of the things that was a unique thing about when the world started having Scrum teams and doing sprints, and testers and devs were now on the same team, right? It's cross-functional teams, and we have a couple of devs and we have a couple of testers. They're working much closer. There's way more collaboration and there's much more focused testing. And early testing, right? In the middle of a user story, when a feature might be half implemented, a developer might have a tester run a couple of tests just incrementally as part of collaborating on the feature. How is this going? How is this part working so far? You get a much earlier agreement on acceptance criteria and on this definition of done and what's going to mean it's done. Testers being on the same team with developers was a great move in that previously, where it had been silos of teams where developers have to be done before testers can take over, there's way more collaboration here and sharing of tasks. When the world did become Agile and we started moving toward, we started doing Scrum and doing more Agile practices, developers did take on a bunch more testing tasks. This next reference I want to use is Brian Marrick's Agile Testing Quadrants. That people probably know from the Crispin Gregory book, Agile Testing. You've probably seen this before. But to do a quick run through, we have Quadrant 1 down in the bottom here, where developers do unit testing and component testing. Quadrant 2, functional tests. Functional meaning as low level as possible, maybe isolated individual function tests. Getting to the level of story tests where you're talking about integration, you're doing user story level, not only acceptance criteria level tests. Moving into Quadrant 3. Sometimes people even call Quadrant 3 the exploratory phase, where we're working on bigger scenarios, usability tests, or whether we get to use UAT, to user acceptance testing, or doing an alpha, doing a beta. But scenarios meaning transactions, workflows, big integration, device, browser, whatever platforms we're going to be running on, and exploratory. This is the hardcore quality engineer, test engineer set of tests that are way more based on how the product is going to be used from a user's perspective, different than a functional test or a component test, where the tests are based on how the code is structured, on the architecture, on the design. And Quadrant 4, performance testing, load testing, security testing, a bunch of the accessibility, some of the other ILITY tests that people run. Quadrant 4 is usually performance and security. But back to Quadrant 3, it's this phase where I worry and I wonder when developers take on more of the testing tasks. I think more testers are confident taking on the Quadrant 1 test, taking on unit and component tests. Getting into the story level, sure, that's a little bit of a stretch, but it's when you get to Quadrant 3, if your developers are taking over tests, this is where I find developers hesitate, right? Doing exploratory testing, it's exploratory testing is such a creative and time-consuming, and it's an art, it's a science, it's based on users, it's based on gray box testing, it's based on how the system was built, it's based on the platform. It has so many aspects of how it's based on experience. Exploratory testing is as based on experience and based on the context of the product, of the users, than the really straightforward technical unit and component tests. So test teams have been, ought to be, particularly skilled at exploratory tests, workflow tests, scenario tests, where developers have traditionally not only shied away from that, but hesitated in taking on a bunch of those tasks. Because they're time consuming, but second, there really is an art and a science to being a good exploratory tester, being able to develop good and worthwhile scenarios and do that user style testing. So when I brought up that idea earlier of saying part of this shift of being able to move testing tasks over to developers or not, part of that is based on how much knowledge do you have of the users. If developers don't really have a great idea of users, and I don't mean this in a bad way, it's, as part of my work, I go out to a whole bunch of companies and I see what they do and I help them, work on their quality practices and how they test. And I meet a whole lot of developers out in the world today who aren't really familiar with what their customers do. They don't have like a tactical knowledge of this is how users do it. Well, I'll tell you one of the main reasons why various clients of mine, what they'll tell me is one of the main reasons why they have bugs and support tickets is because they didn't even realize that customers did certain things. They'll make a bunch of functions, they'll put them out in a workflow that they think people are going to do, or there's some happy path that they think people are going to do. And marketing says we want people to do this, but then when it gets out in the marketplace, customers can do what they want, right? And they might be using your system differently than you guessed that might have limitations that causes bugs. Well, test teams ought to be trained to think from that user's perspective rather than from an architecture or design perspective of how users are going to do things. What are they going to do? How are they going to, how many different ways can they get a certain task done? So, the reason why I wanted to show this testing quadrants thing is not that you're doing quadrants or that you're going to do quadrants or that you like them or you don't, but this idea that there's this whole bunch of tests that test engineers have been and ought to be specifically trained to do. And in my experience, they're tests that developers kind of shy away from. That shy away is a polite way to say this. Sometimes developers are like, no, that's not me. That's not my thing. I don't test that way. I'm not that kind of guy. I'll build the system, but as far as going and doing exploratory testing, that's not me. Another aspect of exploratory testing is, and we'll bring this up later on when we get into testing task, but like error guessing, forced error testing, trying to break the system. Those are, again, tasks that test teams, good, well-trained testers, ought to be uniquely qualified to do. That takes time. It's creative. It's knowing how users might work. It is knowing some of the system limitations or some of the goals of the system and trying to not do that, to force errors, to guess at errors, to do wrong and bad input so that the system handles these cases, the way you want them to be handled, handles them gracefully, right? It handles error conditions gracefully. So, so it's when people talk about moving tasks more to developers, my worry is that they only talk about the low level, like the unit tests or the component level tests, and aren't talking about bigger end-to-end tasks, workflows, exploratory testing. That, in my experience, exploratory tests is what's going to find the worst bugs. Exploratory tests find the bugs that wind up, if we don't do exploratory testing, they wind up being the biggest support nightmares. The part of exploratory testing is looking for gaps, trying to find if the user story, when I brought up that idea of you need great user stories. If you have a good PO and the PO writes good user stories, but every once in a while there's a gap. Part of exploratory testing is not working from the user story, is working from, I'm just going to work from how this UI is done and I'm going to think like a user and I'm not going to pay attention to the user story. That's a great way to find gaps, find alternative uses, find things that the PO hadn't thought about. And if the PO doesn't bring them up, maybe the dev didn't think about them through development, but that's a primary responsibility of exploratory testing, is looking for gaps, looking for things we didn't think about yet as a team. So when the tasks move over, who's going to do those quadrant 3 and quadrant 4 tasks? So let's move on. There's something about DevOps. So for some reason, DevOps is defined. If you had 10 people in a room and asked them what DevOps is, you'd get 10 different definitions of what DevOps is. At its very fundamental level, DevOps is about bringing ops into the dev and QA mix. So you have developers working with quality assurance with test teams that we already were working together in Agile and on Scrum teams, but it brings operations, it brings ops into this mix. So ops is involved the whole time, whether it's using tools for automatic deployments or just bringing operations in early to take care of operations issues early, right? Actually, some people call DevOps Agile for Ops. That it's modernizing operations to keep up with development and testing. DevOps doesn't mean that we get rid of QA teams. It doesn't mean that we get rid of QA teams. It is part of this redistribution of tasks. It doesn't mean that we get rid of QA. It's the three groups working together. So I want to switch to talking about this shift left idea. Shift left is a great idea. I love shift left. I've been talking about it for a while. Imagine we have that traditional development where we have developers doing unit testing, then there's integration testing, then there's system testing, then you move to a staging environment where you might be doing UAT or a pre-production environment, and then you move to production. What shift left means is that we take a bunch of the tasks that we were doing at the end. I think the easiest example for shift left is performance testing. Maybe we weren't doing performance testing till the end. Why wouldn't you do performance testing till the end? Well, because you don't want to do expensive, time-consuming performance testing when the team is running into functional bugs. So I want to make sure all the functional bugs are gone. We wait till performance testing at the end because that might be the best environment to do it on, because the whole system is complete and we're not mocking anymore and everything's in place. The policies are in place and the pointing to the right servers, and it's the closest to production. That's the best time to run performance testing. The problem is when we find performance bugs late in development, they're more costly. So if I can shift some of that performance testing earlier, if I am using a cloud environment where I can have the whole system is built and then just plug in my new development instead of waiting for a staging server to be built, I can run performance testing a whole lot earlier, or infrastructure as code. I can build the whole infrastructure, with the click of a button. I can build my whole infrastructure and run performance testing early. Great. The bugs are cheaper. So shift left is about shifting a bunch of testing responsibilities earlier in the development cycle. Now, I said performance testing is a big example people use, but I think functional testing is the first place where people might do that, where if an old QA style team, an old test team was responsible to do a bunch of functional testing, later on when they got to system testing, by the time they're finding functional bugs in system testing, that's late and that's costly. If we can shift developers to do a whole lot more unit testing, a whole lot more component level or even service level tests, if we can shift those tasks earlier, that's going to pull in the whole schedule. It's going to reduce the quality costs because my testers aren't finding functional bugs where something has to go and be fully rewritten. My testers in a system testing environment can focus more on workflow, integration, usability, those other types of tests I talked about. So shift left is a great practice, and it does mean that developers have been taking on more testing tasks. But those testing tests tended to be unit testing and more lower level component integration tests. Developers or technical tests doing service level tests, API level tests earlier is great. The more we can shift left, the lower the cost, the smoother everything's going to go. Right? Even if I'm just concerned with system testing through the UI, it's a whole lot better if I can test UI-driven workflows where I'm not running into API errors. If those things can already be fixed and kind of taken off the table, my system testing is going to go a lot smoother, a lot less costly. Bug fixes are going to be less costly, and I can focus on those things that system testing is really about. So there's this other notion of quality at every step that we'll bring up in a couple of minutes at Lean practice. But just think about it from the the title of it, quality at every step. Developers write some code, test it, integrate it, test it, move it to another environment, test it. It's that quality at every step is going to lead to higher quality deliveries. So part of shifting left is if we can shift a bunch of the quality responsibility earlier, that's just a saner way to do development these days. But also think, if I'm going to do, this is always a problematic question. If my developers are going to do a whole lot more unit testing, how much can I shift whole testing tasks away from system testing or user acceptance testing earlier into developer testing? Now, I first have a hesitation where I think, okay, does more unit testing mean that I can cut back testing later on in system testing? Maybe. It does mean maybe that if my developers are tasked with finding all the functional bugs, or when I say all, finding as many functional bugs as they can and cleaning up the functionality as much as they can, so by the time it's delivered to a testing environment, it's in pretty good shape, and we can focus on integration type, workflow things. It will reduce, if we do shift some of these testing tests back to developers, it will reduce later stage testing. It doesn't mean that we're never going to find a functional bug in later systems. It doesn't mean that we can't, that we don't have to do functional testing on a system environment, on a user acceptance testing environment. We probably do, but hopefully by that point they might be automated, or that kind of testing can be kept to a minimum. I can run a function on one server, right? And I can run it and it works fine. But then, two development environments later, move to a testing server, then to a staging server. By the time it gets to a staging server, maybe there's something about it that doesn't work. Hopefully we'll find those errors by doing some scenario and workflow errors, or rerunning some of the automated functional tests. So shift left is moving a bunch of the tester work earlier, which is great. It's great. Shift left is a great practice. It's going to cut down the quality costs, but it doesn't mean we don't test later. All right. So I want to talk about lean for a couple of minutes. And this LSD, lean software development. Lean comes from Toyota, right? And the lean software development book, if you haven't read it, get it, the Mary and Tom Poppendick book, Lean Software Development. Lean has kind of taken over software development these days, and let me just get into talking about lean, and we'll talk about what that is. So the 7 lean principles, we're going to talk about eliminating waste. Decide as late as possible, like just-in-time decision-making, just-in-time design, deliver as fast as possible. This deliver as fast as possible is how we get minimum viable product, and deliver as fast as possible for immediate result feedback, and deliver as fast as possible, that continuous delivery, continuous deployment, deliver as fast as possible, continuous integration. Next is this quality at every step idea that we were just talking about. I'm going to save empower the team and see the whole and amplify learning for another topic, because I could spend a long time talking about lean software development. By the way, I will toss out this one thing, amplify learning and what amplify learning means. Finding bugs is amplified learning. Learning about the system, learning how does the system behave under this condition? How does the system behave on that device? How does the system behave when it gets into this error condition? How does the system behave when it gets into that error condition? Amplifying learning is really a foundation practice in lean. And part of learning is finding bugs. So when I say it's a foundation practice, if we say things like deliver as fast as possible, we need to learn as much as we can about the system with the time we have. We need to see as many behaviors as we can before we deliver it. So finding bugs, learning about the system before we deliver it. If we're going to be making decisions as late as possible, doing just-in-time decision-making, we have to amplify our learning to be able to make well-informed, knowledgeable decisions. So amplifying learning is just as important to lean as eliminating waste to me. Eliminating waste is really the first lean principle, that if all you remember about lean is eliminate waste, you'll be pretty good at remembering what lean is about. All these other practices are about eliminating waste. Eliminating waste, like eliminating handoff, waiting, bug fixing, writing features that people aren't going to use. It's why we do minimum viable products, minimum marketable products. So here are the lean practices. This quality at every step that I wanted to focus on. I brought up this distinction between quality assurance and testing earlier, here's where quality assurance comes back, where if we really want a quality product, and we want a lean practice, we want lean, smooth products, we need quality at every step. We need quality user stories. The first step in quality is quality user stories, quality requirements. If you don't have quality user stories, the quality of the product, the quality of the finished delivered product is going to be more difficult, more questionable. It's going to be harder to do. You're probably going to lose some of the speed or some of the cost advantages by not starting with quality user stories. Quality code, quality unit tests, quality test cases, quality automation, quality bug reports, right? If the bug reports don't exactly describe what happens or have the wrong validation point or the wrong actual behavior versus expected behavior, it's going to have an impact on the final quality. Quality test plans. Also, as I talk about lean to people, sometimes they bring up things like quality environments and quality data. Quality is not added into the product at the end, right? You don't have a Q. It's why people stopped using that phrase QA to add quality at the end of the practice. We need quality at every step. And this QA governance that we're thinking about and focused on quality from the start. One thing about QA teams doing testing, even if their main job is testing, QA teams, they do add governance. They do add best practices. They do add, for example, we have test teams at user story reviews and at requirements analysis because they look for different things. They look at user stories in a different way. They look at requirements in a different way than developers who are looking at, when a developer gets a user story, their first job has to be, how am I going to build this? What am I going to do to build this? Where a tester has a different mindset and thinks about what's a user going to do here? How is a user going to do it? What's a user going to do here? So testers add value into this whole set of quality practices. They add quality the whole way along here. And if you're going to have that piece of the puzzle missing, who's going to take over those tasks? So quality at every step is a fundamental cultural kind of working agreement that we need across the team, that test teams have a special place in this quality at every step. Also, when we think about continuous testing or even continuous delivery, quality at every step is you do something and then test it. Do one thing, test it. Like write a chunk of code, test it. Do a build, test it. Package it, test it. Release it, test it. There's testing at every step, but it's not the same testing, right? We write some code, we test it a certain way, right? We're going to do unit testing about that chunk of code. Do a build, then we need to run a smoke test, run the unit test, run a smoke test, so that we can move it to another environment. We move it to that other environment. That's when we might run a full regression suite. It's when we might do our API level, our service level tests. Each of these steps has different or additional tests that run, based on what thing we did. When I say do something and test it, we move it from a server that we're using maybe dummy APIs. We're using mocked out APIs. So we're doing a certain type of testing. When we move it to a server that is running live APIs, we're going to run different tests. We need a different test suite there to run. So do something and test it is the other aspect of this quality at every step. An additional aspect of quality at every step from, quality user stories, quality unit tests, quality bug reports level. So this software culture thing of shift left is more developer testing. That's great. I'm all for developer testing. It's great. We even in the old days, we used to say test early, test often, right? Test early, test often is about as old as testing itself. More developer testing is great. But if it's only developer testing, you have to be careful because we've seen a bunch of tasks that who's going to get those other type tests and when and who is going to do them. With this quality at every step, again, do something, test it. Developers doing more testing. That's great. It's fine. The developers have a much bigger role in this QA thing is great. I'm all for it. But who's going to do the other tasks at these other steps? So I brought up this idea earlier that developers' attitudes about testing. A lot of the developers that I have worked with some of them really resist taking over testing tasks, right? They're fine maybe with doing unit tests. Fine, that's a new way of the world, fine with doing unit tests. But taking over other testing tasks, resist it. And most developers I know haven't really been trained or skilled at that tester type testing. When I say, like I run a test and I run that same test with 5 different pieces of data, or I run a test and I validate that it works, but then I want to run it on the smallest mobile device screen, the biggest mobile device screen, a problem mobile device screen. That kind of tester type testing that we do, that is really beneficial to the quality of the product. That takes time. And most developers haven't been trained to think that way, to have that mindset about those tester type tests. And most developers don't want to go near bigger, longer, high level UI driven automation suites, right? A lot of organizations, if they've trimmed back their test team or they're shifting testing responsibilities, still have inherited very large automation suites, whether it's 1,000 tests or 10,000 tests, 100,000 tests. I have some clients with, more than 1 million automated tests. The developers have inherited these big automated suites is problematic because of how much time they take to maintain, the level of maintenance they need, and keeping them going. But also they provide a security blanket that a lot of organizations are not willing to let go of. They invested a lot of money in getting these security blankets built and getting these big regression suites run. They test differently than unit tests. They find different kinds of bugs than unit tests, right? That's the whole purpose of them. So somebody's got to, maintain them, keep them going, and continue to run them. And a lot of developers I know don't want to go near those things. So starting to pull this puzzle together with this idea of modern SDLCs and this quality assurance and the testing thing. Even if you're doing CI/CD today, which a lot of organizations do, at least the CI part, organizations still need robust smoke tests, right? Not unit level tests, but those kind of build acceptance tests, the build validation tests that are at a higher level than unit tests. They need smoke tests. Well, who's going to write those? I just talked about that idea of full regression suites. Who's going to write them? Yes, but who's going to maintain them? And maintenance on those can be really difficult. If you've cut back on your test teams, a couple of questions I'd want to ask is, who's going to build cross-functional automation, right? We have unit tests, fine. We have some component tests. We might even have some service level tests, but across a variety of functions using the system like your users are going to do it. Who's going to run those kind of tests? Who's going to build validation suites of tests, even happy path suites? If you have a whole bunch of tests at the unit level, that's fine, but more at the acceptance criteria level, the user story level, the UI level, who's going to be writing those suites of tests, and who's going to maintain all these suites? So designing them, building them, debugging them, maintaining them, running them. How much are you going to value those full regression suites, those big automation suites, through the SDLC when you're shifting a bunch of the testing tasks to developers? I will tell you from my experience, most developers don't want to go anywhere near those tests. But also, if my developer's main responsibility, their main job is to write code, right? To build new functionality, to get this, these whatever functionalities, whether it's MVP or whether it's just a new function, out to customers, it's not to get hung up by these full regression suites. And the maintenance and the failure analysis, that alone could keep a test team fully occupied. I know a team that, a company that moved to having developers take over all the testing tests, and the QA teams that were there are gone. And the developers inherited the functional tests for their functional area, right? So this one developer that I talked to, it's a big company, a big application that a whole lot of you would know. It's a publicly traded company. You'd know the company, where this one development team inherited about 4,000 automated tests. And this one developer just threw up his hands with me one day, and he said, I could spend more than half of my day. We do it, they do a daily build, and they run all of these tests in this overnight. to get these daily builds. He said, I come in, even if we get a 90% pass rate or a 95% pass rate, if we run 4,000 tests and we have a 90% pass rate, I still have 400 tests that fail. So even if we have good error codes, at some point, even if it's not 400, I'm going to have to go through a chunk of tests to see why they failed, analyzing them. And some of them could be system errors or timeouts or browser errors or whatever it happens to be. That's time away from developer time, right? Time writing new functions with this inherited regression suite, even with a 90% pass rate. So hopefully it's not that bad in your organization, but I don't mean to say bad, but this is just, I mean, we work in software development, right? We're constantly developing software. Developing software means we have to maintain the tests we have because we're developing new software. It's just a part of running regression suites is maintenance. But if my developer's main job is building new functionality, I don't want my developers spending half of their day maintaining old automated suites and going back and fixing old automated regression suites. So SDLCs are changing, especially with these practices that I've been calling cultural practices, like shift left in quality at every step, moving testing responsibility. Quality and testing is a shared responsibility. It's a shared responsibility starting with the PO, right? From the PO to the test team to the devs, everybody is just as responsible for quality, and it doesn't only land in a test team's lap anymore, which is great. I'm all for that. But it's this redistribution of testing tasks that we have to just be cautious about how we do it. So the next step, I want to talk about developer testing and tester testing, who's going to take over these tasks at a lower level, and who's going to automate them. So moving into the next part of the discussion is developer testing and tester testing.
Thank you for attending part one of our webinar. If this sounds like something you struggle with or need help with, let's set up a conversation with an expert from our team. We will be sending out a recorded version of the webinar within 48 hours, and part two will premiere next week at the same time. Thank you for your time. Goodbye.